This is, as we discussed before, acceleration, velocity, and position, as we know, are all related, right? So we can start with the position function, take its derivative, we get the velocity function, take its derivative, and we get the acceleration function. Likewise, we can start with acceleration and do the antiderivative, so integrate to get velocity, or integrate twice to get that position. Okay, we all know how that's related. We've done this many, many times. Okay, but make sure that you're considering your constants when you do antiderivative, so you always have like a plus c. So a lot of times those plus c's are like your initial velocity, initial height, right, your initial values. So it says in many real-life problems, we will be using the same acceleration. So our acceleration due to gravity. So our acceleration due to gravity, if you were in physics, you probably know that it's negative 9.8 meters per second squared. So have you guys all seen that number? You know that number? All right, so in physics, we typically use meters per second squared because, surprise, the rest of the world uses meters. And for some reason, in the US, we use feet. So we might also see negative 32 feet per second squared. So you're using one of those numbers to start with on almost all of these problems. So number one, it says if a diving platform is 20 feet above the surface of the water and a diver starts with an initial velocity of 6 feet per second, what is the diver's velocity at impact? Okay, we have to consider gravity in this situation. So we're starting with the acceleration due to gravity. Are we going to use negative 9.8 or are we going to use negative 32? Negative 32, because in our problem we have 20 feet, right, and 6 feet per second. So when we integrate, we get our velocity function, which is negative 32t plus c. So when we do these problems, our c value is our initial velocity. We've done many of these before. I think you guys probably remember these. So it's saying when I plug in times 0, I get a certain value for c. Well, my initial velocity, v of 0, is equal to 6. So all of that is equal to 6. Do you guys see how c works out to be 6 then? So sometimes you can kind of just skip this step and you can say, oh, my velocity function is going to be negative 32t plus that initial velocity, 6. Okay, why did I say in the upward direction?
So it's positive instead of negative?
Yeah, it's positive instead of negative. So the diver is jumping up off the board, right? They're not just like falling into
Well, I mean, they could like
They
jump.
could. Could they shoot themselves into the, I don't know.
mean,
I
if
think if
you're
you're
on
following your initial velocity.
If you're on the
0.
very end, you could like do like this directly into it, which I've seen people do before.
I don't know. All right, so anyway, so what is the diver's velocity at impact? So we're trying to find the velocity when they hit the water. So we still need to find our position function, right? We need to know what's happening. So our position function is going to be the antiderivative of this. So that's where we get our negative 16t squared plus 6t plus, what does the constant for this one end up being? 20. So we can put like d, and you can plug in times 0 and say, oh, but my initial position was 20 feet above the surface of the water, so d ends up being 20. Or you can just skip directly to s equals negative 16t squared plus 6t plus 20.
And now s equals 0?
So we're finding when the position equals 0. We want to know when you hit the water. So we're letting 0 be our water. Okay? Many of you guys might remember something that's in every math textbook from Algebra 2 on, which is the formula s of t equals negative 16t squared plus v sub ot plus h sub 0. So the initial height and initial position, or initial velocity, I mean. Does this make sense? Do you guys see that? Do we see where that comes from? Okay, that comes from calculus. Yay, calculus. All right, so we're going to find where this is all equal to 0. So I have 0 equals negative 16t squared plus 6t plus 20. So you can do this a couple different ways. You could factor, right? Does it factor nicely? Did you guys try? No? You can do quadratic formula, or you can be lazy and use your calculator, which is probably what I'm going to do. And I'm going to plug that in for my y1, and I'm going to find where it crosses the axis. So I'm going to do y equals negative 16t squared, so x squared, plus 6x plus 20. And I'm going to hit graph. So it's probably going to be a pretty tiny time, right, for a diver to hit the water. Probably not going to be like 500 seconds. So it's pretty close there, so you need to adjust your window. So we're going to do second trace, 0, and we're going to find that. So my left bound is a little bit above the axis. My right bound was a little below. Hit enter. So I got 1.321. Okay, so I'm going to go back to my main screen. I'm going to hit X, and I'm going to store that just in case I need it. So I have 1.321. So if we're finding the velocity at impact, then I plug that number into the velocity equation. So I'm going to take that number, and I'm multiplying by negative 32, so times negative 32. And then I'm going to add it to 6. So your answer should be negative 36.277.
You only use like the S function to do the graph.
Yeah, it kind of depends on what you're asking. So in this case, we were asking when do they hit? Like when are they hitting the water? Well, if our water is 0 for our height, we're finding when it's equal to 0.
Like if you didn't need to find, which I know you will need to find it, but if you didn't need to find that point on the graph, you wouldn't have needed this.
Yeah, usually you'll need all three.
Did you plug in the rounded answer, or did you plug in the actual?
I used the answer button, I think, on my calculator.
So, what was your
So
T? What was your 0?
I got T was 1.321.
Because I got 1.277, which I don't know how that.
Yeah,
I'm
I
seeing
didn't
both
check
of
your.
us.
Does everybody else have what I had? Okay. So maybe check your negative 16
Yeah,
and
I
your 6
mistyped
and 20.
something. So,
All right, so number 2. So these are a little bit different. So these are the ones that I was kind of saying we did something like this in pre-calc, but it's been a long time, so we're kind of putting this all together. All right, so it says a golf ball is hit from the ground with an initial velocity of 130 feet per second at an angle of 30 degrees. So find an equation for the height of the ball at any time t. So when we hit a golf ball, there are 2 components to the velocity. Okay, there is a horizontal component and there's a vertical component. Okay, so we're going to hit this golf ball at an angle of 30 degrees, and our velocity component going in this direction is our, I often call it v sub x, so our x component for the velocity, and our component on this one is v sub y. Okay, and we get these using SOHCAHTOA. So our velocity was 130 feet per second. So that was in that, like, along the hypotenuse. Okay, so we have a little right triangle that's created. Okay, do you guys kind of remember these from pre-calc? So if I want to solve for Vy, so I'll do this one time, and then once you see where it comes from, you'll be like, oh, every time it's going to be this. Okay, if I'm solving for Vy, I'm using these 3 numbers. I'm using my 30, my 130, and my V sub y. So use SOHCAHTOA to set up an equation. What would we do to get the y component? Sine. So I would set it up, and I'd be like, okay, I have the sine of 30 degrees is equal to my y component for the velocity divided by the hypotenuse, which is 130. Do you guys all see that Vy is going to be 130 times sine of 30? So it's kind of like our magnitude times our sine of the angle. What do you guys think V sub x is going to be? Exactly. So we set it up and we say cosine of 30 is equal to V sub x over 130. So our x component is going to be 130 times cosine of 30. Now think about why that makes sense. Like even on your unit circle, like the cosine is your x value, the sine is the y value. Like that's where it's coming from. The x component uses cosine, the y component uses sine. Okay? So if we're talking about the equation for the height, are we talking about the y direction or the x direction? The y direction. Okay? So our velocity isn't actually, we can't start it out and be like, oh, my velocity is 130. Because it's not. It's going a certain speed in the x direction and a certain speed in the y direction. So did you guys find 130 times sine of 30?
65.
Yeah, it's 65. Why does that make sense? Because sine of 30 is 1/2, right? So this is all equal to 65. So about half of its speed is going upwards and half of, not half, but the rest of its speed is going the other direction. Okay, so what are we going to do? So we're going to do our velocity in the y component was 65. What about our acceleration? What's our acceleration in the y component?
0.
No, because it's going to come down, right? Negative 32, right? So our velocity, when I'm finding that v sub y, that's my initial velocity. So my velocity equation is going to be negative 32t plus that initial velocity, which we talked about before. So you could put a c there and then plug in times 0, but we're going to get that. And our initial position, which is our height equation, ends up being negative 16 t squared plus 65 t plus 0. Why is it 0? Because it starts on the ground, right? Actually, maybe it's on a t, which is like a little quarter of an inch off the ground. I don't know.
No one
How do you find A?
The acceleration, it's due to gravity. So acceleration is always negative 32 or negative 9.8. We're using one of those two numbers.
You're on the fairway, you don't get a T, you're not driving it here. Just to make this more simple.
Oh, really? You don't get a T when you're on the...
I don't think so.
I don't know much about golf.
Nor do I, and just assume, I don't remember what my dad did wrong.
All right.
Why do we use the y velocities for these to show?
Because we're talking about how quickly it's going up and down or right and left. So in this case, we're using the height equation, which is up and down. So if we want to know, like we did these in pre-calculus where we were like, how is it possible for this ball to be hit at this certain speed and angle, and does it go over the fence at Wrigley? I don't know. So you like figure out how far it goes out in that time and how high it is during that time. So we need the x and y components. All right, so B, so it does determine the maximum height and the amount of time the ball spins in the air. So how do I get the maximum height? Well, I have my height equation.
Assume your position equation, right?
I have my my position equation. So I could take the derivative and set it equal to 0. In other words, what am I setting equal to 0 to find the maximum height? I'm setting my velocity equal to 0. So I'm setting the velocity equation equal to 0. Well, my velocity equation was negative 32t plus 65. So we're going to get a time there. So it's going to be whatever 65 over 32 is.
2.03125.
So we can just use that, or you can store the answer, 2.03125. It comes out nice and even, I guess. So now it says the amount of time the ball spins in the air. So we need to figure out when it hits the ground, right?
Wait, I thought that T is the amount of time.
T is,
Wait,
oh, I haven't found the maximum height yet, have I? So I need to find the position at 2.03125. So if I plug that into the position equation, which was here, I have negative 16 times that answer squared plus 65 times my answer, and then plus 0. So what do we get for that maximum height?
66.016.
So that's my maximum height. Okay, so if I want to find the amount of time a ball spins in the air, a lot of times I do this the same way every single time. I find how long it's in the air by setting my position equal to 0, right? My height equal to 0. And then I can, that's going to be my t, how long it was in the air. So we can do that, and you can go to your calculator and you can put in this position equation. Or you could actually just factor out a t and solve it. So if I do that, and I'll show you a shortcut too, but so if I do that and I pull out a t, I get negative 16t plus 65. I can solve for t. So it ends up being 65 over 16. How's that related to that last number I found?
It's double.
It's exactly double. Okay, this does not always happen. Explain to me why this happened in this particular situation.
It started off at the same level that it landed.
Exactly, because you're starting at the ground and it's going up and it's coming down and it's hitting the ground. So when you have a situation like that, your time at its maximum height, which was 66, or not time, sorry, our time was 2.03125. This is double that time when it hits the ground because I started on the ground. But if I'm playing golf at, you know, that thing that's going to be next to IKEA, all these IKEAs have these like golf places next to them. I think like, you know, people drop off their people. I would say wives. I don't want to be too sexist. Drop off their wives at IKEA. I love IKEA. And I think they go and golf. And so they always build these next to IKEA. But let's say I'm 50 feet up at this golf place and I'm hitting it, right? It's not going to be exactly half. Do you guys understand that?
There's a giant IKEA.
I know.
A giant golf course next to the IKEA
Always,
warehouse I always
yeah.
fly over when I'm flying out of Newark.
Yep.
There's a giant
So
golf
find the
course.
horizontal distance that the ball has traveled. So now we want to know the horizontal distance. If you are throwing a ball horizontally, and I didn't have gravity in play, that ball would go on forever.
Yay.
Right?
Until it
So
comes
if I
back and
throw
hits
a
you.
football, and I just have that rocket arm, and I'm just throwing it, and it's going forever. It's never falling down if I don't have gravity. You guys get that?
Assuming you throw it directly straight.
So the thing that's dropping it is gravity. So that's why we have the x component and the y component. So the x component is going to use this v sub x. So v sub x is 130 cosine of 30. Which you can find a decimal approximation if you want.
112.583.
Okay, thanks,
I
Ian.
found that in the first part because I didn't realize we were allowed to just keep it as.
So we can find that decimal approximation. And our position function then in the x direction is every second I gain 112.583 feet. That's pretty fast. So my position function in the x direction is going to be 112.583 t. That's all it is. There's no like acceleration due to gravity that's pulling it down or anything. If there was no gravity, it would continue in that direction. Benjamin, wake up. All right, so what's the horizontal distance the ball has traveled in? How do I find that?
You just multiply 4.0625 times that number.
Yeah, we're going to plug in how long it was in the air into this equation. So we get 457.370 feet. Yeah, that's pretty far. Professional golfer. Mine would be like 3 feet. Mine doesn't really get off the ground. Does yours get off the ground? I mean, it's not pretty. All right, so number 3. So it has been reported that basketball star Michael Jordan had a vertical leap of 54 inches. Pretty tall. Did we?
Yeah.
Ignoring air resistance, what is the initial velocity required to jump this high? Maybe he stole my notes. I don't know. Did he use my picture and everything?
Yeah.
Totally stealing my notes.
Who did this?
All right. So if we have a vertical leap of 54 inches. Okay, so we're going to go through this. So what do I always start with? Acceleration. And my acceleration, if I'm in inches, oh man, let's put this in feet. How far is 54 inches? How many feet is that?
2.5. Oh wait,
Yeah,
54?
if you subtract out 48 inches, that's
54. Never mind.
54.
I thought you were talking about 30. Never mind. Yeah, 4.5.
Yeah, so we have 4.5 feet. Okay, so we're going to make that 4.5 feet. That's going to make our lives a lot easier because personally, I don't know what the acceleration due to gravity is in inches. That sounds like a pain.
I think that's,
We're just gonna stick with our
negative
negative 32.
Just convert it into.
I know how to do it, yes.
2.5.
So our velocity, I don't know it off the top of my head. I do not have that number memorized. All right, so our velocity function is going to be negative 32 t plus our initial velocity. We don't know what the initial velocity is. It has to be something good because he's pushing off the ground at a certain speed. We don't know what it is, though. So I'm going to write v sub o. So this is a tricky question. Now our position function. Our position function is negative 16 t squared plus v sub o times t plus our initial height. Well, what's the initial height? 0. So we want for him to go a total of 54 inches, right? 4.5 feet. So we're going to set our position function equal to 4.5. So we need to solve this. Man, I'm like totally forgetting how to do this. I know I should know how to do it. Any ideas? That's what you do when you're a teacher. Any ideas? I know it's a system of equations. Turn it into a quadratic? How do we do that? Well, what are we going to put in our calculator? We have 2 unknowns, right? We have that v sub o. We could set v sub o equal to, but we have v there, don't we? So what's our velocity? I got it now. What's our velocity when he's at that point?
0.
So our velocity is equal to 0
At 4.
when he's at the height of 4.5 feet. Yeah. Oh, skip into the next part. So negative 32t plus v sub o. So we're going to solve for v sub o. And at that point in time, v sub o is equal to 32t. Do we see that?
V sub O is equal. Oh, yeah.
So now we take that 32t and we replace our v sub o with it.
4.5.
So we have 0 equals negative 16t squared plus 32t times t. So 32t squared if you want,
So equals 16t squared.
minus 4.5. I'm adding that over here to get positive. Right, I'm solving for v sub o. So I get 16t squared minus 4.5. So I'm going to add that 4.5 over, and I'm going to divide by 16 to get that time.
T is equal to 0.520.
Yep, so t squared is equal to 0.28125. So when we take the square root of that answer, we get 0.530. So that's how many seconds it takes. And I have that in my calculator. So it's 0.53033000859. Okay? Okay, so our question is, well, what's the initial velocity required to jump this high? So where do we go back to? We go back to right here. So v sub o is equal to 32 times that 0.530, which I have in my calculator. Oops. I did multiply by 30, not 32. All right, so we end up getting v sub o equals 16.971. And that's in feet per second.
Are we supposed to convert it into?
You can if you want to. If you want to know how quick that is in miles per hour or something, you
Let's
could.
say in inches. The problem starts out in
Nah.
inches.
I'm fine with that. All right, so the last one is still one of these x and y component ones. So it says a human cannonball is launched at an angle of 30 degrees. Oh, I did 30 again. That's no fun. Let's make it something else.
60 to 30.
Stick with 30?
Yeah, why not?
I don't know. We'll stick with 30, I guess. So 30 degrees. So we're going to have that Vx and Vy, right? So the x and y components. Our Vx is going to be, our 49 was our speed, right? So it's going to be 49 times cosine of 30. And our Vy is going to be 49 times sine of 30. And we know that because we could do SOHCAHTOA to get those values. So it says determine the time of the flight and how far away the cushion should be placed on the ground and the height of the human as at the maximum. Okay, so let's see. So I think we want both our x and y equations, right? So let's go with our vertical first. So our acceleration is negative, oh, now we're in meters per second though, so we're going to use negative 9.8. I know, I prefer negative 9.8 as well, all those physics classes. So I have negative 9.8 t plus our initial velocity, which was in the y direction, so it's half of 49.
34.5.
So that's our velocity in the vertical direction. Because sine of 30 is 1/2, so multiply by 49. All right, and then our initial position then is negative 4.9 t squared. So I integrated negative 9.8 t.
So why both times have you used v sub y?
Because I'm talking about vertical directions, the y
Both
component,
times?
and x is the horizontal.
Is that the initial position or the always position is negative 4.9 t squared plus 24.5?
I mean, it's, you know how we have this formula here?
Oh, you just made
This
it
is
for
in
the
feet
thing
per
there.
second. The other one, the other version of that will always be negative 4.9 t squared
Oh,
plus v sub o t plus h sub o.
oh,
That will be
because
for
you
meters
keep
per
saying
second.
Initial position when you're like
This
for the
is
thing
feet
you
per
add on
second,
to the end. Never mind. I keep thinking you're saying the equation. Like you should. Sorry.
So if that's in feet, if your final thing's in feet, you use negative 16. If your final thing's in meters, you use negative 4.9. All right, and then what's our initial position? I guess he's going from the ground, right?
That is assumed so.
Yeah, I didn't say how high he was.
Wait,
It's kind of
but
weird.
if it's
Fired from out of the ground.
if it's a cannon,
I know.
mean,
I don't know. Here's the ground. He's here.
so
They're firing him from out of
they
here.
put a little
I
trapdoor
don't know.
underneath the circus stage, and they have the cannon come out. And
All right. I don't know, Ian. Overthinking. All right, let's go. So our horizontal. So we're trying to figure out when he hits the ground. So if we're finding when he hits the ground, we're setting all of this equal to 0. So we have negative 4.9 t squared plus 24.5 t equals 0. And we're going to pull out t. So we can solve it. So when we solve it, we subtract that 24.5 over, and we divide by negative 4.9.
So you get exactly 5.
We do. And the other one is 0, which doesn't make any sense. So 5 seconds. So we want to know where to put the cushion, which is kind of important for this poor human cannonball. So we're going to do horizontal. So we take our velocity, which was v sub x, and it is 49 times cosine of 30. I'm going to leave it like that. So that means our position is 49 times cosine of 30 times t. So we take that 5 seconds, and we multiply it by 49 cosine of 30. So its position after 5 seconds is 212.176 feet. Now,
Meters.
oh, meters, dang.
How'd you get S is equal to 0?
I'm setting s equal to 0 to find when he hits the ground, to where to put the cushion. So, why is this a dangerous thing to do if you don't have a knowledge of physics as well? It is dangerous, period. Maybe don't do this for risk assessment. Don't do this.
He also asked us to find the height of the human.
So, Charles, what else would you consider if you were in a physics class? You would consider like air resistance and things like that. So maybe get a giant cushion if you're going to do this to someone with only your limited physics knowledge. And this is why you should take physics classes, right? All right, so we're going to stop here.
Wait, so did we find the height at maximum?